Go.
Go? Okay. All right. So what we are going to talk about now is the concept of limiting reagent. In real life, we do not have perfect amounts of reactants and products where they react completely with each other, okay? In real life, we have one reactant that is more than what we need and another reactant that is not enough. And some of them will finish the reaction first before the other one will be completely used up, okay? So this is the concept, and I always give an example about the peanut butter and jelly sandwich. So if you wanna make peanut butter and jelly sandwich, you need 3 reactants: peanut butter, jelly, and bread, correct? Okay. So I say I have a jar of peanut butter, a jar of jelly, and 2 slices of bread. 2. How many sandwiches can I make? Just 1 sandwich, considering that, yeah, 2 slices make a sandwich. Okay. So my limiting reagent, by reagent I mean a reactant, is the reactant that's going to be consumed completely in the reaction. Bread is my reactant that's going to be consumed completely because it's going to be transformed into product, into the sandwich. The other reactants that are not limiting are called excess reagent, and that's your peanut butter and your jelly, because if it were for the peanut butter and the jelly, you could make more than 1 sandwich. So your product would be increased, but in reality you can't, because the bread is not enough to make more than 1 sandwich. Okay, so this is the concept of the limiting reagent. The limiting reagent is used up in the reaction, and the limiting reagent determines the amount of product. 1 sandwich, not 20 sandwiches, as it could have been based on the other 2 reactants. Okay, so limiting reagent is a reactant. These are reactants. These are products. Limiting reagents cannot be products. So if you have a question on the test, when you have out of these 4, which one can be the limiting reagent, you have a 50-50 chance to hit it, even without doing any calculation if you choose the reagents, the reactants. Okay, I have students that choose limiting reagent among the products, like, okay, not good, okay? So the other reactant that is not limiting by default is called the excess reagent. Some of that excess reagent is used up to make your product, and some of it is left over unreactant, floating around the reaction environment there, okay? So that's the limiting, not the excess. How do we recognize that we have a limiting reagent problem? The problem has to give me the amount of both reactants, okay? That is a red flag that you have a limiting reagent. And how do you solve it? By doing the math twice, as a stoichiometry problem done twice, one with one reactant, the other one with the other reactant. It's as simple as that. It's a double stoichiometry problem. So if we're looking at the problem that we just did 5 minutes ago, 120 grams of sulfuric acid reacts with NaOH, and you calculated the grams of Na2SO4. Perfect. This was not the limiting reagent because I only give you 120 grams of H2SO4. What if I change this and I say react 120 grams of H2SO4 react with 80 grams of NaOH? So I'm giving you the second reactant. I'm giving you the amount of second reactant. This is now a limiting reagent because you have an issue. From 120 grams of H2SO4, you can calculate how much Na2SO4 you can make. And you can also calculate using the NaOH how much Na2SO4 you can make, okay? And comparing the 2 answers, basically you choose the smallest answer, the 1 sandwich, not the 20 sandwiches that you could have made. The smallest answer, you do the calculation twice. You're going to calculate X, and then you're going to calculate a Y based on the NaOH. And between the X and the Y, the 2 answers, you choose the smallest. The smallest answer is the correct answer. Okay? The smallest answer is the answer that comes from the limiting reagent. So let's solve this like a limiting reagent problem. So step 1 and 2, balance the reaction and underline the given and the wanted. The given now is sulfuric acid and NaOH, and the wanted product is the sodium sulfate. Good? The grams. Step 3 is turn what's given to you into moles. So step 3, you have 120 grams of H2SO4. You have to turn them into moles of H2SO4. And then you have 80 grams of NaOH. You have to turn them into moles of NaOH. So that is step 3 done twice for both reactants. Okay? 120 grams, we've seen that the molar mass of H2SO4 is 98, so I divide this by 98, and I get 1.22 moles of H2SO4. And the molar mass of NaOH is 40, so I divide this by 40, and I get 2 moles of NaOH. So far, so good? So I'm doing step 3 twice. Now I'm going to do step 4 twice. Step 4 in the stoichiometry problem says calculate your product based on the given information. So from H2SO4, I want to see how many moles of Na2SO4 I'm going to get. And I have 1.22 over 1 is X over 1. So 1.22 over 1 is X. We've seen this before, X over 1. And that is X is 1.22 moles of Na2SO4. That is your first answer. And then you're going to do the same calculation based on NaOH. So from NaOH, you're going to see how much the same sodium sulfate you get. So I'm going to set it up. NaOH, I have 2 moles. 2 the coefficient underneath, y, and 1 the coefficient underneath. So I have 2 over 2 equals y over 1, with y equals 1 mole, right? I'm getting 1 mole of Na2SO4. And now, this is the thing. I can get 1 mole, or I can get 1.22 moles. Which one is the correct answer? From sulfuric acid, if I use all my sulfuric acid, I'm getting 1.22 moles of Na2SO4. If I use all my NaOH, I'm getting just 1 mole of Na2SO4. Which one is the correct answer? The smallest answer is always the correct answer, because 1 is smaller than 1.22. This is the correct answer. This is the amount of Na2SO4 that I can actually make. This is called the theoretical yield. The theoretical yield is the correct amount that comes out through calculations. The theoretical yield is always the smallest number that comes out through your calculation, the moles and the grams, whatever it is. Okay? So to finish up this problem, step 5 would be turn your moles into grams, because they want grams. So I don't know where to put it. Step 5 would be right here. 1 mole of Na2SO4, turn it into grams by multiplying by 142 was the molar mass. Oh, so it's 142 grams of Na2SO4. Okay, so the answer is 142, and you've seen that the first time we did the problem, before we introduced the 80 grams, we got a different answer. We got a little bit more than that. Well, I cannot get more now because this 80 grams kind of doesn't let me do it. So if I'm looking at these two answers at 1.22 moles and 1 mole that I get here in step 4, and I determine that this is the smallest amount, so this is the correct amount, I'm always looking, who gave me that amount? What was the reactant that led me to that answer? It was NaOH. That makes NaOH the limiting reagent.
Where did we get the 142 from?
The molar mass of Na2SO4 was 142. Right? So NaOH is your limiting reagent because it led you to the smallest amount of product. Na2SO4 is your product. So NaOH, limiting reagent, leads you to the theoretical yield. What about H2SO4? H2SO4 in this case is my excess reagent. Some of these 1.22 moles of H2SO4 will be used up, and some of it will be left over unreacted. Good? Okay. So that's an example of a problem like this. What do I have here on the slides?